Example 5 says a U.S. Coast Guard patrol boat leaves Port Canaveral and averages 35 knots, which are nautical miles per hour, traveling for 2 hours on a course of 34 degrees and then 3 hours on a course of 124 degrees. What is the boat's bearing and distance from Port Canaveral? Have y'all talked about bearings before?
No.
Okay, so just watch up here. You don't have to write this down, but let's talk about how they do bearings. There's 2 ways to do bearings. The first way, which is not what this problem has it set up as, is if you see a bearing, it might say like north 50 degrees west. And so either way, we're going to use a compass rose. Remember, it's got your north, your south, your west, and your east, right? And so what this does is it says from the north, we would go 50 degrees towards the west. So we would make an angle right here that would be 50 degrees.
Okay.
All right? Or it might say,
NCSW.
it might say south, I'll just use the 50 degrees, south 50 degrees like towards the east. So from the south, we would go 50 degrees towards the east, and so this little angle right there would be 50 degrees. All right, that's one way they can do it. Another way is kind of like what this problem's doing. I should have just used the eraser. This took longer. All right, so this problem says they went on a course of 34 degrees. So if they don't give you any directional stuff, you're always going to start at the north, and you're going to go clockwise. So from the north, we would go clockwise for 34 degrees. And so it's going to form that angle. So anytime it tells you it has a bearing or you're changing course or something like that, you're going to use a little compass rose to help you find that angle. So let's look at this problem. All right, it tells us here that they're averaging 35 knots, traveling for 2 hours on a course of 34 degrees. So we're starting here at A, that's our Port Canaveral. And so if I drew in my compass rose, from the north, going clockwise, we would go 34 degrees. So that's how they got that little angle there. Now, they're on that course at how many knots? 35, which remember are nautical miles per hour, for 2 hours. How far are they going to go? 70 nautical miles, okay? Then they're going to change course. So they're going to go to this point, which we just called B, and they're going to change course. So we're going to draw another compass rose here. And they're going to go 3 hours on a course of 124 degrees. So from the north, we would go clockwise 124 degrees. So that's how they got that angle right there. They're on that course for 3 hours at that 35 knots. How far are they going to travel on that course? 105 nautical miles. And then they're here at C. And this is where our boat is at. Okay, the patrol boat. So wants to know its bearing and the distance from Port Canaveral. So if we're at Port Canaveral, how far is it to go straight to the boat, and what bearing would it be?
It would be the hypotenuse.
Well, yeah, this side over here. Well, we can't say it's hypotenuse, but I know what you mean, because we can't tell for sure that that's a right triangle. So there's our distance that we're after, right? Uh-oh, I just lost it. Hold on. Sorry. I was trying to change color of my pen. So we're after the distance right here. And we're also after the bearing. So from the north to that dashed line is our bearing. Yes, sir.
How did you get 105 again?
Because it was, how did I get 105? It was 35 knots for 3 hours.
Oh, okay.
Okay. All right, so what are we going to do? Good question, right?
No one's 90 degrees.
Which one?
So left. Who knows that left angle is 90 or not?
We don't know.
Find D and then divide by 2.
Well, here's my theory, guys. if you're looking at it and you're like, I don't know where to start finding what you can find. Okay? Because eventually, if you find what you can find, you'll end up with what you need. So, something I'd seen, how would you find angle C?
Well, you'd have to find the theta from the 34 degrees, so it would be like,
How about this? What about this little angle right here? How could I find that little angle right there?
180 subtract minus 120.
Yeah, because that one and that 124 add together to be a straight line, which is 180 degrees, right? So what's 180 minus 124?
56.
All right, so we know that little one's 56.
Let me find another one now.
All right, how?
180 minus 56.
Mmm.
No, 90 minus. Or,
We don't know that's a 90. We can't say that.
If the other side's a straight line, the other side has to be, right? I can't.
Right, but we don't know anything about those angles on the other side, do we?
but you can find them.
There is a way up here that you can find this little angle here. There is something up there that'll help me find it.
34.
How?
The distances? Couldn't you do?
Yeah.
Like
By
tangent?
finding the other, the
You could find the,
data, and then solve the other way.
How about this one? Remember, I know it's a way back, but geometry.
Saying random stuff.
We've got two parallel lines right there, right? Our compass roses. And they're being cut by a transversal. And alternate interior angles are equal, aren't they?
So it's 34.
So that 34 degrees is equal to the one that I drew the two lines on there.
Wait, so
Yeah.
34 is equal to...
That's what you were saying, right?
The 34 is equal to that angle right there beside the 56.
I thought we could solve for it.
So he was right, there was 34, just couldn't quite give me a reason, and it's because it's an alternate interior angle with the 34 degrees, and alternate interior angles are equal. So we do know that this is 30, oops, that this is 34
It adds up to
degrees.
90.
Ah, so now we can say this is a right triangle. Good. So now we've proven that that's a right triangle.
Solve for everything. A squared plus B squared.
Okay, we can find D because we can use Pythagorean theorem, right?
No.
All right, so that's one of the things we're after. So our distance,
70 squared plus.
find it. We know that. What is D? Is that going to be our A, B, or C?
One of the...
It's the C. It's the hypotenuse. So we know that A squared plus B squared equals C squared.
How many people are going to come in this class?
So 70 squared plus 105 squared equals D squared.
Had to get some.
Okay, so if we're going to solve for D, we could do all this and take the square root, right? So D is approximately what number?
126.2.
19.
126.19, and it's in nautical miles.
Knots.
All right, so we found that. Now we have to find is our bearing, right? Well, look at your bearing. What can you tell about it?
That it is acute.
I'm not real sure the bearing's acute.
Yes. It is.
You think so? No, because remember the bearing is that 34 degrees plus theta, isn't it?
Yes.
So, well, how about let's do that. So we know our bearing is equal to 34 degrees plus theta. Because right here, you see where I'm drawing?
Because you're a genius.
That's my bearing.
It's
From the
flat.
north to that dashed line.
Oh, okay.
So if I knew theta, we'd just plug it in and solve, wouldn't we? Good, let's find theta.
You something. Tangent.
Well, we know that the middle between the two triangles is 90 degrees. And we know 34.
Tangent.
I don't know that this is 90 degrees down here, so that doesn't work.
How do we not know that?
The
Opposite.
Because it's not actually.
transversal
So,
line that goes through.
So,
How we found 34, we just find it for the other angle. Because we know that the one on top is 90.
Ooh, boy.
Okay. Good question, good question. Okay, look, I'm about to draw all over this and then I'm going to erase it again, okay? All right, so what he's trying to say is if we have these two, I think now, parallel lines, right? He's trying to say that this angle and this angle are equal, aren't they?
No.
Yes.
The only problem is you see that little piece underneath that line there? That's part of theta. So if theta landed on that line, then we could, but we can't. Okay? That's a good thought, though. Good thought. That's what we got to do, is to go through and see what would work. But,
Wait, why can't we find the side and then use that too?
Why don't you just use tangent?
yeah, I'm thinking we got a right triangle there, correct? We know two of the sides, don't we?
3 the side.
So we can use an inverse function to find an angle? Yes.
What?
So let's look at this. All right, so if I'm after just theta right here, okay?
Okay, yeah.
What is the 105 to theta? Opposite, what's a 70? And so we could use
Inverse.
tangent, right? So tangent of theta equals opposite over adjacent. So tangent of theta is equal to 105 over 70.
Oh, okay, okay.
And then you inverse.
And then we do the inverse because we're looking for the angle. So it's going to be the inverse tangent of 105 over 70 to give us theta. So make sure you're in degree mode. And what is theta?
This calculator sucks. I can't go up to talk to my hands.
Oh, I'm in radian.
It should be like
56.
56.31.
Good, 56.31 degrees. So now that's not my answer. That's helping me get my answer, right? Because now I'm going to take and plug this in over here. Because we know that our bearing is 34 degrees plus theta. Theta is 56.31 degrees.
80.31 degrees.
Add them together and we get 90.31 degrees. And so there is our bearing.